distribution on artificial reefs, oil rigs, and natural habitats. No, but I'm reading the wrong one. Let's redo that.
Yeah.
So attraction versus production. Sorry, he was down for the same two talks. Cheap sheet.
I don't think yours is up there.
Isn't mine not on there
No,
yet?
I think you both put it in the back. That's mine.
Oh, okay. I can
Okay,
put it
well,
on
I'm
right
just
here.
pulling that up.
Got it.
Getting that straight. Attraction
The
versus
fat
production
one.
in
Yeah,
a
sorry
grand
about that. I
artificial
thought they moved
experiment, red
copies
snapper
here
in the
too.
Gulf of Mexico.
Thanks, Greg. Let me bear with me while I get this off of here. And you were spared me talking twice. Fortunately, Mandy was able to give that talk, so I didn't have to speak twice, which I didn't want to have to do. All right, let me put this on. Is there some place you need this to stream it?
No, they have it in the back.
Okay.
Yeah.
All right. All right, I guess I have to watch what I say because it's being streamed, right? All right, so as we alluded to with the last question, we're trying to put this into the population level context. In particular, what does this mean for the stock assessment? And so the question is that's really the question I'm going to try to answer, at least from a hypothesis testing standpoint, as to what are the likely implications of this and what is the likely mechanism by which anything might be happening as we've put all of these structures down in the Gulf of Mexico. And so we've already seen this map of all these, the structures, the rigs, and then artificial structures, and that doesn't even begin to account for the chicken coops and the appliances and other things that people have been voluntarily putting into the Gulf. So I just want to thank my co-authors, Mandy, who talked before, Matthew Smith, Shannon Cascale, Clay Porch, and Dan Gethel. I am kind of in a fortuitous position in that I don't actually do the stock assessment of red snapper, and unfortunately, many of my co-authors are not. They will be doing the upcoming stock assessment. So I think this is probably why we're here, the attraction-production debate. It's kind of the existential debate about artificial reefs. Do they actually simply attract biomass, or do they produce new biomass? And the implications of that are pretty substantial in terms of how we're going to use them and what we're going to do in a fisheries management context. So we really won't even dwell on that. One thing that we do know about artificial reefs and these artificial structures is that we have a time series of how they've been put into the water. The blue line are oil platforms over time, really starting in about the 1960s. The red line is artificial structures that have shown, artificial reefs primarily, that have shown a fairly substantial and steep increase since 1990, with a lot of efforts by states and stakeholder groups to formally put these structures in the water. But we're also seeing a downtrend in the oil platforms as those are being either reefed or removed. So that's actually a tendency where those are going down. So overall, the total structures in the water has been flat now, the yellow line, in the recent years. So in terms of red snapper and artificial structures, there's some things we know, and then there's a lot of things we don't. What we do know from Mandy's talk is that only about 0.15% of the total area in the Gulf of Mexico has one of these structures around it, if you assume that they have a radius of influence of about 100 square meters. We could debate that one way or the other, but in general, the fraction of the bottom that has this stuff is really, really small compared to natural reefs and compared to the total habitat in the bottom. We know red snapper actually use undifferentiated mud habitat. So most of the red snapper are on other locations. However, about 13% of the age 1 and 2 red snapper are probably on these structures. We also know that these artificial structures, and I'll use the term AS from here on out just to simplify it, that it has moved some of the spawning biomass. You see that when the Alabama Artificial Reef Zone was put in, before that, Mandy's plot showed no biomass there. Now there's biomass. Some of those fish are spawning. That's actually moved spawning biomass. We don't think that red snapper exhibit very strong spawning migrations, that they often spawn where they are. And so that would have moved some spawning biomass, potentially altering either the distribution of eggs and larvae, potentially altering recruitment. But we don't know what the implications. We also know that red snapper don't settle onto artificial reefs or platforms. for the most part, they seem to like to settle on smaller non-structured habitat like oyster shells and things like that. But from talks we saw earlier today and from some of the research that suggests that they actually are either precluded from settling out because of conspecifics, or they're actually eaten or precluded from actually settling on oil platforms. This is in contrast to the oil platforms in the Gulf off of California that presumably a lot of the rockfishes directly settle out of the larvae and out of the water column. We also know that if you build it, they will come. So the Strike, an earlier paper by Strike, and we saw Matt's talk earlier, was that if you do a backy design where you study something before you put it there, and afterwards you will actually find red snapper in an area that didn't have red snapper. What we don't know about that is whether you're actually pulling red snapper from somewhere else they would otherwise be. So the challenge we have is really a challenge of scale. We can do small scale studies and see before, after we get an impact, but what we don't know is what that did through other parts of the area of the fish. And so that's really the challenge, is dealing with the scale issue. And so that's where the stock assessment has the ability to operate on the scale, because it's taking all of the data and all of the removals, and it might be the way that you kind of actually disentangle attraction versus production. Also, we know the artificial structures are fishing hotspots. They've increased. We don't know what the population level impacts are. If they're fishing hotspots and they're simply attracting, then perhaps it's actually a negative for the population. But the other thing we know is that the latest stock assessment for red snapper estimates that recruitment in the recent time period from 1983 to 2014 is about 70% higher than historically. We don't have a mechanism for this. We don't have any reason. It just looks like it's more probable that we are seeing increased recruitment. So why is the question? So if it's production, it's pretty simple. It could only be through three mechanisms. It can either make more fish, either through recruitment, fecundity, or settlement. It can either increase growth rate, or it can increase survival. And some of the mechanisms for increasing survival is that artificial structures provide a refugia from shrimp trawling bycatch, because as we saw the net tangled on an oil rig, you can't trawl across it. So presumably this leads us directly to parameters in a stock assessment that could be tested. Each one of these is a specific parameter in an assessment model. However, oftentimes when you have an assessment, you don't let growth vary, so kind of all the sludge goes into recruitment deviations. The fish could not grow. The model says that they just didn't recruit. The fish could have higher mortality. It just said they didn't recruit. But I'm going to try to partition those mechanisms out in the assessment. If it's attraction, then it's changing catchability. Again, a parameter in the assessment. That's the fraction of the populations that's captured in a unit of effort. So the CPUE, at least from the Karnauskas paper, says it's 20 times higher on artificial reefs than on natural reefs, and on platforms than natural reefs. If that's simply increasing catchability where the fish are attracted to that, it's just a hotspot for fishing, and the fishing removals are taking them away. Conversely, most of our surveys, our scientific surveys, operate not on artificial structures. They either have to avoid oil rigs because you can't set a long line across them, or you can't interfere with the petroleum industry. So a lot of our surveys don't operate on these artificial structures, which has been a criticism of the NIMS surveys, that they don't sample the fish where fishermen are fishing for them. And so we get a lot of criticism that the feds are underestimating the population of red snapper because they're not counting them. What is being done is that there's an assumption that the relative trends in abundance are the same for the natural structures as for the artificial structures. And the biology is the same between those two. Barring evidence to the contrary, that's the assumption that's been made in the stock assessment. So what I've set up in this was an explicit test of the attraction production hypothesis. So what if they attract, then catchability should change, and it should change differentially between our fishery dependent and our fishery independent surveys. And then if they produce, then growth, recruitment, or mortality should also change with this index that we have of artificial structures. So by putting that vector of time series in as an environmental time series, I can link that to a specific parameter in the model. So the linkage is done by where the parameter, the estimated parameter p hat, is equal to the baseline parameter times exp times a beta coefficient, which is the coefficient linking the significance of the environmental time series, which is e to the t, with the parameter estimate. So I can explicitly test that beta parameter of whether the environmental effect is significant or not. I can also test in an information criteria or information theoretic approach whether the model with the environmental time series is a better fit to the data than the model without. So the methods I'm using, the stock assessment from CDAR 31, it's been updated over a number of years and evolved. It's starts in 1875. It's got 14 fleets, 18 indices, 21 fleets and surveys, 14 discard fleets, over 1,200 parameters, and it's probably the most complicated stock assessment that at least we do in the Southeast. It might be the most complicated assessment in the nation. There's two regions, east and west of the Mississippi River. They have one stock recruitment relationship, and then recruitment is partitioned differentially between the east and the west. So the hypotheses that I'm testing and the models that I'm testing 9 different models, and this is important. The first model is the null model with no artificial reef time series. The second model is the base stock assessment model, and that has a split in the absolute level of recruitment starting in 1983. So it's estimating this higher level of recruitment in 1983. That's the baseline model. Then I'm testing R0, which is stock assessment talk for virgin recruitment, as a function of the artificial reef index. The hypothesis is that the index predicts the absolute level of recruitment. The fourth one is that the recruitment deviations, and that's the interannual variability in recruitment, is driven by the artificial structure index. Then the fifth model is that the K on the von Bertalanffy growth is driven by that. So that's testing, does growth change, and has it changed over time with that? Sixth one is whether natural mortality has changed, because presumably age 0 mortality may have changed with that, where the fish may be now protected as they're young by being on artificial structures. And then 3 hypotheses that test the catchability of whether fish are being attracted to, and a combination of the catchability and a change in production. So testing simply catchability alone and then catchability plus a change in production, either through virgin recruitment or recruitment deviations. And then this is the definition of the parameters. So there's some caveats. The stock assessment model is an imperfect hypothesis testing tool. It's not the most rigorous hypothesis testing tool because of a lot of the caveats about the data that we're using and the fact that it's got many, many parameters in it. Also, a lot of the tests based on information theory rely on the model assumptions being correct, and quite often those modeled assumptions are in some violation. So if I reject the hypothesis, it's not implying that causation is driving this. It's saying that the data and the assumption of the model are favoring this hypothesis. Then I'm also equating oil platforms with artificial structures or artificial reefs. Those two may not be biologically equivalent in both area or impact. And then the model is not using the age length data or the length composition data. So this is an important caveat that I will allude to later. We're not using the odal age length pairs in the stock assessment. Probably when you see the results, you'd say, you know, that actually is something that we need to incorporate to be able to determine if really some of these things are happening. And then I'm also testing primarily a single factor at a time, and it's likely that a lot of this stuff interacts. So the results. And so the AICC is the corrected Akiiki's information criteria. A lower value of that says a model that is a better fitting model. And so then I've calculated the deviation from the null model of no environmental effect, and then put it in words, whether it's better than the null, so you don't have to do the math or think about the math. And then the environmental parameter and its standard error. If it's greater than 0 or than 2 standard errors away from 0, then it's generally speaking significant. And then the environmental parameter either on K or M naught. So basically the model with the best fit is the model that allows growth to vary, and that's model 5. And any of the models that allow for a change in productivity over time are better fitting than a model that doesn't. And it's probably easier for me to show this than to show this table, but this is the table by which one would select which hypothesis is the best fit. So this is the estimated recruitment time series with 7.0, just go back to the catchability. Catchability is not favored by, a change is not favored by any of the models, which suggests that it's production rather than attraction that is favored by this set of data. The estimated recruitments time series, and you can see in the most recent time period, the recruitments are all much higher than in the historical time period. And that's a pattern in the data independent of including the artificial reef or not. So even in the null model where no environment is, or no artificial structure index is included, that seems to be a pattern that there's some increasing recruitment. However, the model that fits the best is with the change in growth, and that's the red line, which shows that the recruitment in the past is fairly equal to the recruitment in the future. So that's an important distinction which says that change in growth could better explain what the model is otherwise explaining through a lot of recruitment. So it gets to a mechanism that we can evaluate, has growth changed? And then I'll show in the next slide what that change in growth means. But in most of these situations where you have this offset between the historical recruitment time period and the new, it's because it's saying that either a second time period of higher recruitment is now the new normal, or the artificial reef index is saying it should be increased now because it's following that index. So this is the estimated K parameter as a function of the artificial reef index, showing that the K, the von Bertalanffy K, is increased fairly substantially. I don't necessarily know that I believe this because in the next slide I'll show that the size at age doesn't match our observed size at age. But what it's saying is that the model favors or could explain this increased productivity by simply faster growth and a larger size at age. The model fit to the age 0 M shows that it prefers a much lower M for age 0 over time if it fits that index, but that's a much worse fit to the data. So we would reject that as the plausible mechanism. Here's the estimated growth over time, allowing K to vary in each year with the artificial structure index. And then on the right side is the predicted versus observed size at age. The dashed line is the growth curve size at age. The dots are observed size at age. So the model is saying they should be much larger at age than what we see in the actual data or what we see in the growth curve. So I don't necessarily believe this. It's just saying that you could equally explain what's going on by a change in growth. That change in growth seems somewhat unnatural to me, but again, we're not using the raw otolith data in the model, and I think that really what we need to do to further explore this is actually put that data in the model. The current model uses the catch at age that's derived from that data rather than putting the raw data itself in. This increased growth is consistent with Strike, the paper by Strike, but it's inconsistent with other studies that have shown reduced growth on artificial structures, either due to crowding or higher densities. And that's Sari, Kormanek, Schwarzkopf, and Cowan. So right now, we have conflicting evidence from the process studies. This is the link on catchability. How much time do I have?
Yeah, you got a couple minutes.
Okay. There's not a consistent pattern in the catchability. What I would expect is for the fishery-dependent indices, the ones where there's recreational fishing index, 2 of them, east and west, I would expect that to increase with the artificial structures because most recreational fishing is on artificial structures now. The headboat index I would also expect to increase. And I would actually expect the surveys to decrease if my hypothesis about attraction either towards those structures or then away from those structures, because it's got to work both ways if it's simply an attraction. And the evidence is mixed. Also, the fits are not particularly good for that, and the parameter estimates usually bound 0, so they're not significant anyway. So I color-coded the fishery-dependent and the fishery-independent indices, but it looks like at least catchability can't explain the changes in productivity. So revisiting the hypotheses and coming back around to making some sense out of this, the Q change is not favored by the data. The best fit is obtained by allowing the K in the von Bert growth equation to change, but the magnitude of the change doesn't fit the data. What it suggests is that there's probably something else going on. Then allowing the age 0M to vary did not improve the fit, which suggests that it doesn't seem like it's an increase in survival that's going on. So in conclusion, it looks like the model evidence doesn't favor attraction. So the direction of the Q changes are inconsistent, and attraction itself can't reconcile the historical and recent recruitment. Second, the modeling suggests increased production potentially by growth, because growth can say it wasn't recruitment, it was actually just growth that did that. But it requires further evaluation, I think explicit inputting of the growth data to determine whether that plausible mechanism is appropriate. The other thing I will admit is that simply varying the von Bertalanffy K is kind of cheating in a way, because growth, it's really 3 parameters of the growth equation that interact. So probably what I would need to do is allow all of the growth to vary, but I would want to put the data in itself to allow that to happen. So this was sort of a quick and dirty way of allowing one parameter to change rather than allowing all of the growth to work. Then, even without the artificial structure index, the model wants to have recent recruitment higher than historical. So all of that change can't be explained by artificial structures. And in fact, the magnitude of the productivity increase is substantially higher than could possibly even happen, since only 15.15% of the area has artificial structures. So even if the structures were increasing productivity by the percentage that the fish, of 13% of the fish that are on it, the productivity increase we're seeing now is even greater. So something else is going on. It seems to co-vary with the artificial structure index, but we still don't know the mechanism. So the next steps are to ask the question using connectivity models and of whether moving 8% of the spawning biomass changes recruitment, and then to integrate the modeling of growth into the actual assessment, and then also try to estimate natural mortality in the assessment. So with that, I'll stop right here. Thanks.
We have time for one quick question.
John, in the western Gulf of Mexico, where the red snapper biomass is greatest, the time series of increasing nutrients seems to match what you're showing here. You know, it overlaps with this period of increase of artificial habitat. So I'm wondering if you've looked at nitrogen or any other nutrients to see how they potentially explain some of this variance.
I haven't, and it's got to be something else. It can't just be the artificial structures doing this. So I'm open to hypotheses.
If there's a few more questions, we're going on to a break. If you need to step out before we get to that, one other thing is Steve Bartone's talk was moved earlier in the session, so we won't pick up until 3:40. But if there's some more questions, we're on a break. So
Okay.
Jeff, go ahead.
No, I just wanted to say that in the Mediterranean, where I've looked at the fisheries productivity from the 1970s, there has been a very clear increase in landings and productivity as that you can associate with nutrient runoff from land. And there's actually figures on the nitrogen runoff for some areas. So, and also there's figures for alpha phytoplankton levels in the thing. So you can actually establish by the satellite imagery whether there's been an increase in nutrients or not. At least that seemed to be the case for the Mediterranean.
Thanks for all your hard work on what you're doing here. I'm just going to quote Dr. Bob Shipp when he asked, pertaining to the artificial reefing system off of Alabama, which has been accounting for about 35 to 40% of all the recreationally caught red snapper in the Gulf of Mexico, and an unknown amount of the commercially caught. If those reefs are not producing those fish, then where in the heck are they being attracted from?
I think that we saw in Mandy's talk that actually that does look like there's production there. And I think the assessment is not in disagreement that there's increased production. In terms of, is increased production of the magnitude of the increase in artificial structures, is that the slope? I think that's the question that is probably not, and most definitely not all across the Gulf of Mexico, because that increase in structures hasn't occurred equally across the Gulf. The Western Gulf is actually seen a decline because most of the rigs have been removed. But that Alabama artificial reef zone really had very few snapper prior to that, and that's what Mandy's analysis would say. Put it in, and you get red snapper there. So, but in terms of how much magnitude that's pulling from it looks like you're not getting a substantial decline in the indices that would be occurring on areas that were not part of that reef zone. So that's the catchability test. The indices off it should be going down, and the ones that are on it should be going up. And so you should get an opposite trend, and that I didn't see.
John, with the Q, I'm curious why you allowed that to vary across the fishery-independent indices, which don't actually target the artificial reefs, and not just restrict that to the fishery-dependent indices.
Because if it's attraction to an area that they don't sample, then they should be in opposite directions. So if the surveys, so the bottom long line survey can't go on permitted artificial reefs or oil rigs. So they're sampling natural habitats. So presumably if the fish are just all piling into the oil platforms, they're moving away from the surveys and right into the teeth of the fishery-dependent indices. And that's why I thought that there should be a differential direction.
All right, well, thanks. Oh, go ahead.
So I think at the moment the biggest management problem we have in the Gulf of Mexico is the recreational red snapper season has gotten so short that it's created a lot of problems. And I guess what I'm trying to sort out from this is, okay, artificial reefs, apparently we're getting some increase in productivity, but we're also seeing catch rates that are 20 times higher on the artificial reefs. So I'm trying to get out what's the net impact of all these reefs on the recreational season. Is the productivity increase enough that it more than offsets the high catch rates? Or are artificial reefs and adding more and more out there actually causing the season to get shorter because the catch rates are so high? Are we at a point where you can tease that apart yet or draw any conclusions from that, or is it too early?
Right now, I had hoped to be able to do that, but I don't think that I can without identifying better the mechanism for an increase in productivity. And I think that the increase in productivity commensurate with the increase in platforms, it sounds like plenty of other factors could have occurred at the same time. But your point is exactly the point that I made in a question before, that this reef symposium has to kind of deal with from a management perspective, does putting all these platforms and structures in the environment, presumably to benefit the fishing community, actually working against them because of the way fisheries management works?
Yeah, and I think that's really important because I'd like to know, are we spending a lot of money to create the very problem that is making us all miserable? But I think it's great work, and I hope you'll give us an answer someday.
All right, well, thanks, everyone. Yeah, we'll be meeting at the thing, so I don't want to keep everybody in here since we're running very long. But symposium tonight, we'll pick up here at 3:40. Reception tonight at 6 o'clock at the Marriott. And we'll meet Steve Schroeder's talk. We'll